Hello everyone. Today we're going to be looking at section 4.8 on page 351, which is applying what we have now learned about trig functions and their inverses to solve problems. Some of them will be word problems, today's will not. Today we will just be talking about right triangles. Before we can begin, I need to explain something that can be found on page 284 in your textbook. And it's basically when you have a degree that's not written as a decimal, it's written with these symbols here. This is called a prime, and then the double apostrophe is called double prime. Okay, so let's do an example. So let's say the problem had this 85 degrees, and then they had 18 with a prime, and let's say 30 with a double prime. Okay, the one with the prime stands for M, which stands for minutes, and the one with the double prime stands for seconds, okay, which is what S stands for. So what we need to do is we need to change this because we want a number that's written as a decimal so that we can use the calculator. See, this right here you can't use in your calculator. Only some calculators you can use the prime and the double prime. But for most you can't. So what we're going to do is we're going to convert this to be a decimal. So we want the final answer to be 85 point something something. We don't want this notation. So think about what I said. This we need to change. So if this is minutes, think about how many minutes would be in an hour. So we would say 60. Now, whatever that is going to get added to now 30 seconds. Think about seconds. So you know that there are 60 seconds in a minute, and there are 60 minutes in an hour. So 60 times 60, that would be 3,600. Okay? So what we're going to do is, using the calculator, take 18 divided by 60, and if you want, pause the video and try it. See if you can get the same answer I am. So 18 over 60 plus 30 over 3,600, and that will be approximately 0.308. There are more decimals after, but we're just going to round right there. All right, so now whatever this is going to get now added to your 85, and so you would have 85.308. All right, so again, I'm just going over this in case you see a problem that's written in this format, and so now you know what the method is to get it into be a decimal instead of having that notation. Okay, now let's go back to page 351. I'm going to show you a typical problem, and I think you're going to find that this is very easy compared to the other stuff we've been doing. So let's take a right triangle. Okay? And let's say that the only thing you know, and we'll call this triangle ABC. So let's say the only thing you know about this triangle is that this side is 5, and let's say angle A is 50.1 degrees. And then you're told that you have to find everything else. You have to find the remaining sides and the remaining angle. Of course, that would happen during my video. The angle part's easy. You guys had an amazing geometry teacher, so you know that there are 180 degrees in a triangle, and you know that this guy is already 90 and this is 50.1. So if you want, pause the video and you can figure out for me what angle C would be. And now that you're back, you should have figured it out, that it is 39.9 degrees. Okay, so now we have found the angles. Now we still have to find two of the sides. We obviously can't use Pythagorean theorem because with Pythagorean, we would need to know one more side. So instead, what we're going to use is SOHCAHTOA. So Let's just pick an angle we would want to use. I'm going to go with using this one here, 50.1. So if I'm using 50.1, then 5 represents the adjacent. This side here represents the opposite. And this side is always the hypotenuse. The one across the 90 is always the hypotenuse. Okay? So I'm going to find my opposite first. So what can I use? Well, if I already know adjacent and opposite, what part is SOHCAHTOA? The TOA part. So I'm going to set it up. Tan, and make sure your calculator is in degree mode since we are dealing with degrees in this problem. So tan of 50.1 is equal to opposite, which you could just call x if you want, over adjacent. All right, now what would you do if you want to pause this video and see if you could get the answer? Multiplying 5 by both sides, plugging that all into my calculator, I will result in approximately 5.97 for my opposite. Okay, so now I know that this opposite here is 5.97. Now you have two options. You could use another trig function to find the hypotenuse. So you could use, if you want sine, you could say sine of 39.9 is equal to opposite, which would be, what would be the opposite? Would be 5 over the hypotenuse. And you could solve it that way, right? We would take hypotenuse, multiply it. We would divide that sine, so hypotenuse would equal 5 over sine of 39.9. Okay, you could put that in your calculator and you would result in the hypotenuse being 7.81, and you would be done. I'm sure some of you were thinking, well, why didn't we just at that point use the Pythagorean theorem? The answer is you can. So you could also have just done 5 squared plus 5.97 squared equals c squared and resulted in the same answer. Okay, that's the beauty of this, is that there are many ways to do the problem. Okay, now let's take it a step further. Let's say, I'm going to just scroll down here. Let's say that originally, this is a terrible triangle. Let me try again. Sorry about that. Okay, I will try better. Okay, so let's say you had been given a triangle, but you didn't know the angles. Let's say you had just been given sides. So for example, let's say they had told you that you had 5 here and 5.97 here, and you didn't know what these were. Okay, let's call this A, and let's call this B. Okay, so think about that. What would you have done? Well, what will give us an angle measurement? If you've learned anything from section 4.7, you know that this would be using inverses. So for example, if I'm looking for angle A here, I would say, well, what information I have again? This is the opposite and this is the adjacent. So I would be using tangent, but not tangent. I would be using tan inverse. Okay, tan inverse. And then I would put in opposite over adjacent. And the inverse function is what's going to give you the angle measurement. Okay, so when you do that, you should get approximately 50.1 degrees. Okay, so remember that. And that's the main point I want to make, is that when you're looking for sides, we're going to be using the basic trig functions. And when we're looking for the angle measurements, we're going to be using their inverses. Got it? I hope this lesson was pretty simple, and I'll talk to you guys soon.